The measurement system validation in Step 10 gave us final confirmation of the validity of any cycle time data we collect. Now the goal in Step 11 is to statistically confirm that the improvements have positively impacted the loan application process. Click Next to continue. Confirmation in Six Sigma means statistics that will back up your decisions. I know not everyone loves stats, but the good news is, in Step 11, we are using calculations that you have already learned. When you get finished with this step, you will be able to apply the process capability and hypothesis testing that you learned in Analyze to the control phase. Click Next to continue. You may be thinking that it's been a while since Analyze, and it's not entirely clear why these tests are repeated during control. Siggy sent over this Step 11 background material to put the task we are about to do in context. Select the folder and we'll review it together. All previous steps have led us to believe that using a new electronic form and highlighting the required fields will improve the loan application process in the commercial loan sales office. But remember that reaching Six Sigma requires in-depth statistical analysis. Based on the Six Sigma process, you believe that those improvements will have a beneficial impact on your Project Y of reducing loan application processing time, but have you statistically confirmed that it does? Process capability is the measure for how a process is performing, so to verify that our process is doing better, we need to recalculate that number now. You'll actually recalculate during the pilot phase to see if the capability has improved. Then, calculate it again after the improvement has gone live in the workplace. The second real-world calculation should only happen after enough time has passed to allow sufficient sampling and the process is believed to be in control. For the purpose of this training, that means after you have completed the control task presented in Step 12. A second type of improvement evidence is the result from a hypothesis test. In the loan sales case, that will mean hypothesizing that there has been a change in the loan application process versus no change in the process. Since this entails comparing the mean of the original data collected on the loan application cycle time with the data collected after the improvement, and since this is continuous data, a two-sample t-test is the best choice of analysis. Now that you understand why we are performing these analyses, let's get to it. Click Next to continue. Since we haven't decided on our control strategies in the workplace yet, we are going to be evaluating the capability of the pilot process. As always, we've got to begin with the data. This data was collected over the course of a 1.5-month pilot of the new process. The time was measured between receipt of the electronic application via email and its electronic submission via email to the credit bureau. Generating the process capability report for this data in Minitab, as you learned to do in Step 4 of the Analyze phase, we get the following summary of the sigma values. And comparing those numbers to the original Z-bench scores for this loan application process, has the process improved? Yes, it has improved. There is an improvement of about a half sigma in the process capability, and most importantly, the defects per million opportunities has dropped from over 217,000 to around 24,000. This is statistical confirmation that in the pilot testing environment, the improvements made to the X's have had a positive impact on the Project Y. This report should be generated once again on measurements of the process and its full implementation for confirmation of the process improvement in the real world. The final confirmation of success in the commercial loan sales case is the result from a hypothesis test because it provides 95% confidence in our decision that we've made an improvement. Which answer best describes our hypothesis for this test? Good. The answer is A. Your null hypothesis is the status quo, in this case that there has been no improvement. Your alternative hypothesis should represent a change. In this case, that means the time is less. Click Next to view the test results. To review what we covered in this lesson, you should now be able to apply what you learned in the Analyze phase. To evaluate the process capability and hypothesis test results for statistical confirmation of the process improvements. Click Next to continue. and in the commercial loan sales case, with a higher sigma score, dramatically lower defects per million opportunities, and the definitive results of a hypothesis test, we can now confirm that the process improvements made during the improve phase have had a positive impact on the project goal of reducing loan application processing time. Click Next to continue. Well, time flies when you are having fun. I told you I enjoyed my work, didn't I? We've reached the end of Step 11 and you're almost at the end of DMAIC. Click Next to go on to the final step and decide on the control and therefore the last step in Six Sigma. Now is the time to make the final decisions on how to control the process in its full implementation and complete the commercial loan sales case. Click Next to begin the final step. You were introduced to the components of a process control system back in Step 10, but we weren't ready to decide on the control strategies for the commercial loan sales office yet, because we hadn't validated a measurement system or confirmed the improvement in the pilot site. Now that we can be sure that the improvements are sound in a pilot environment, we're ready to set up the control system for full implementation. In this lesson, you'll learn to describe the options for controlling the process, starting with risk management. The second strategy to be considered is mistake proofing. And finally, there are statistical process control charts. The latter is perhaps the most complex of the three mechanisms, so you'll be guided through the different types of charts available, and the creation and evaluation of one commonly used chart. We've got a lot of ground to cover before we're done with this case, so click Next to continue. Options. Here's a reminder of the X's that we need to control at GE Commercial Loan Sales. Keep them in mind as you are learning about the strategies, and we'll come back to the case towards the end of this lesson. Here are the three mechanisms you can choose from to maintain your process improvement. They are not exactly sequential, meaning that you don't try risk management first, then mistake proofing, and then SPC. However, there is somewhat of a hierarchy. Risk management and mistake proofing should be considered before resorting to SPC because they are strategies for avoiding potential problems altogether, whereas SPC can only monitor for potential problems. This becomes more apparent as we look at each one in more detail. Click Next to start with risk management. The risk management process is similar to the failure modes and effects analysis covered in the measure phase. However, now the focus is on identifying risk to the X's, the sub-processes or product characteristics that were improved. Both tools ask you to attach a score to the risk. With the FMEA, the risk priority number is calculated by multiplying severity times frequency of occurrence times detectability, while the risk management score is impact times probability. The two formulas use different terms, but really severity and impact are synonymous, and so are frequency of occurrence and probability. The key difference is that detectability is also included in the FMEA score. Risk management provides a systematic method for identifying risk elements that might interfere with improvement and control, quantifying those elements, establishing a risk abatement plan, and continuously monitoring the progress of the plan. It is a clear method of communicating risks to management and drives clear decisions on risks. This is a sample risk management document. Select each numbered area to hear how it relates to the steps in the process. Then click Next to learn about mistake proofing or Tell Me More for more information on the risk management process. In this area, potential risks to your improved processes or product characteristics are identified through a description and a type classification. In this area, the risks are rated according to probability of occurrence and impact on the process. Charts are available in the resources section of this course to determine those ratings. Those two factors are multiplied to give the issue an overall score. Once the risk is identified and rated, a plan is established for abatement, responsibility is assigned, and a measure of success is established. Finally, the abatement plan is monitored for completion. When the plan is complete, the probability and occurrence should be revised, the risk score recalculated, and that number entered as residual risk. The approach to process control is mistake proofing. As I mentioned before, mistake proofing is a method for avoiding errors in a process, so it should be considered prior to utilizing statistical process control. The simplest definition I can give is Mistake proofing is a technique for eliminating errors by making it impossible to make mistakes in the process. Click Next to continue. The traditional approach to controlling a process was inspection. The problem with inspection is it allowed errors to continue, caused wasted time and money, as well as customer dissatisfaction due to defect, and relied on the abilities of the inspector to catch the defects. The mistake-proofing process instead takes action on the original cause of errors. By brainstorming sources of errors using tools such as the fishbone chart, taking actions on the errors, and thus preventing defects from occurring. It is this attention to process improvement that will take us to Six Sigma performance. How you mistake-proof a process is different with every situation. As a green belt, it will be your responsibility to brainstorm mistake-proofing solutions for processes in your work. So I want to give you an opportunity to practice thinking in this manner. Here are a few processes to consider. How could they be mistake-proofed? Type some ideas in each field, then click Done to continue. For some additional information on mistake-proofing techniques, you can also click Tell me more. There is no one right answer to these challenges. Here are some ideas to compare yours with. If you want some more challenges and solutions, click Tell me more. When you're ready, click Next to go on. Unfortunately, mistake-proofing is not always possible or economically practical. When that is the case, you must use statistical process control, or SPC, to keep your improvements in control. An SPC chart is essentially a feedback system. It's a time-ordered plot of the data that provides a statistical signal when special cause variation is present in a process so that you can take actions to eliminate it. Generating such charts requires ongoing data collection on a process, so you can see why it would be a second choice to mistake-proofing. Think of a process mapped on an SPC chart like a car driving along a highway. The yellow lines defining a lane represent the expected variation for the process. The car might wiggle back and forth a little in its lane. That is inherent to the driving process. But when the car heads outside of the lane, there is some special cause interfering, like the driver talking on his cell phone. When the police see that driver getting out of control, they can intervene. However, for most processes, it is not easy to see when they begin to move out of control. That is why you collect measurements and create SPC charts and data, because they give you the ability to detect and act upon special causes that are impacting the process performance. That is the basic idea behind statistical process control, but it is not quite that simple. There are several different types of charts and many data patterns you should be aware of. Click Next to examine them in more detail.